our group assessment. My name is Fang Xin. This is ECM 740 Advantage Digital Communication Multiple Access Technique in Telecommunication OFDMA. Our group assessment have two people, one people Imran and me. About the multiple access multiplexing. It's a means used for multiple users to share the same communication channel, which allow multiple users to transmit data simulators without interference with each other. In communication systems, the main object of multiple access technology it is to make effective use of linked sprinting results to achieve high fidelity and effective communication. The multiple access technique used in communication systems often have the four regions. First one is FDMA, frequency division multiple access, dividing the sprint into different sub-carrier bands. Each user is allowed a separate band to transmit data. The number two is TDMA, time division multiple access, dividing time into no-overlapping time slope, with different users transmitting data in different time slope. The number three is CDMA, code division multiple access, spreading the user data using different spread structure and transmit them simultaneously at the same time and frequency. The last one is the OFDMA. This is our today the important topic. Orthogonal frequency division multiple access. Dividing the sprint into different sub-carrier bands and using OFDMA to transmit data from the multiple user simulators at the same time and frequency. And what is OFDMA? I think it's a multiple access technology with its advice by dividing the sprint into different sub-carrier bands and transmitting data from the multiple user simulators at the same time and frequency. Each user is allowed to a set of orthogonal sub-carriers, making them independent of each other and no interference. The implementation of OFDMA is based on the OFDM technology, in which data is split into several proto subcarriers for transmission. Each subcarrier has an independent frequency and path and they are orthogonal to each other. For example, there is no multiple interference in the frequency domain by allocating data to different users on each subcarrier. OFDMA allows multiple users to share the same frequency result at the same time. In OFDMA, the available bandwidth is divided into small subcarriers in order to increase the overall performance. Now the data is transmitted through these small subcarriers. It is widely used in the 5G technology.
Okay guys, I will talk about the comparison between multiple access techniques. First of all, how it works. As mentioned before, OFDMA divides the bandwidth into orthogonal subcarriers and assigns each user a set of subcarriers. FDMA divides the bandwidth into frequency bands and assigns each user a single non-overlapping band. TDMA divides the time into slots from the same frequency band and assigns each user a single slot. CDMA is by using a spread spectrum technology encoding scheme to assign each user or signal with a unique code. CSMA is by sensing the traffic on the shared transmission medium for idle traffic before it starts initiating the transmission. The advantages are OFDMA has efficient use of bandwidth, good performance in high traffic conditions, robust to interference, and support high data rate. FDMA and TDMA, it is simple to implement, easy to manage, and support a large numbers of users. CDMA, it is robust to interference, supports a large numbers of users. CSMA, it has efficient use of bandwidth, good performance, but in low traffic conditions. The disadvantages are OFDMA requires complex signal processing. It also can be sensitive to frequency selective fading. FDMA and TDMA, it is not as efficient as OFDMA in high traffic conditions. It can be sensitive to interference. CDMA is not as efficient as OFDMA in terms of bandwidth usage. It can be difficult to implement. CSMA, meanwhile, not as efficient as OFDMA in terms of bandwidth usage. It can lead to the collision of data. OFDMA is being used in 4G LTE, 5G new radio, and Wi-Fi 6. FDMA and TDMA were used in second generation and third generation networks, CDMA in third generation and fourth generation networks, CSMA in Wi-Fi 5, and also it is being used together with OFDMA in Wi-Fi 6. Why OFDMA in 5G networks? As mentioned before, it has efficient use of bandwidth. This is because the frequency band is divided into a number of orthogonal subcarriers. It also robust to interference because of these orthogonal subcarriers. Orthogonal subcarriers means that the signal it carries is mathematically independent from other subcarriers. This is because each signal in each subcarrier doesn't have common features that can cause an interference or collision. OFDMA also support for high data rates because of the flexibility of allocating the subcarriers when required. OFDMA also support for heterogeneous networks. OFDMA is scalable, which means that it can be easily adapted in different network sizes and traffic conditions. The number of subcarriers is usually based on the power of 2, 256, 124, and etc. OFDMA also has dynamic resource allocation. It can allocate subcarriers and power resources based on the user requirement. And to mention that OFDMA is also backward compatible with the legacy system. It can exist or can be implemented alongside all the communication system. Variation of OFDMA in 5G networks. First of all, the single carrier OFDMA. This is a simplified version of OFDMA that uses single carrier instead of multiple subcarriers. This makes it simpler to implement. Multi-carrier OFDMA is more complex version of OFDMA that uses multiple subcarriers. This allows for higher data rates and more flexibility in allocating subcarriers. Sparse OFDMA is a variation of OFDMA that uses a smaller number of subcarriers than traditional OFDMA. This can improve the performance of OFDMA in networks with high levels of interference. OFDMA also can be combined with other multiple access such as FDMA, TDMA, and also, as mentioned before, it is being used together with CSMA collision avoidance in Wi-Fi 6.